Welcome, my dear friend. Welcome to another journey through the cosmos. And tonight, tonight, we're going to witness something truly extraordinary. Something that's happening right now, even as you're settling in to listen. Did you know that while you've been lying there, getting comfortable, about 4,600 stars have just been born? That's right. In the time it took you to find this video and press play, 4,600 new stars have ignited their first light somewhere in the universe. By the time tonight's journey ends, over 400,000 new stars will have begun their cosmic lives. And we're going to drift through the stellar nurseries where these miracles happen, watching stars being born in the most peaceful, gentle way imaginable. And you know, if you're finding some comfort in these cosmic wonders already, if the thought of drifting through stellar nurseries sounds peaceful to you, I'd be so grateful if you'd gently tap that like button. It really helps other sleepy souls find these journeys too. And maybe, if you'd like more of these cosmic adventures, you could subscribe. That way we can meet here again and again, exploring the universe together. I'd also love to hear in the comments what cosmic mysteries help you drift off to sleep. Maybe it's the vastness of space or the gentle glow of distant stars. But there's no pressure at all. We're just here together, you and me, ready to float through the most beautiful stellar nurseries in existence. Now, let's help you settle in even deeper. Take a nice, slow breath with me, breathing in the peace of this moment and breathing out any tension from your day. That's it. Perfect. Feel yourself sinking just a little deeper into your bed, into your pillow. You know, your body is like a nebula right now. All the busy particles of your day are starting to slow down, starting to settle, just like cosmic dust settling into clouds. And with each breath, you're becoming lighter, more ready to float. Your mind is clearing like a patch of space between the stars, making room for the wonders we're about to see. Feel your shoulders releasing, your jaw softening. Even your thoughts are slowing down now, drifting like gentle stellar winds. There's nothing you need to do, nowhere you need to be, except right here, floating with me through the Achatitom cosmos. And isn't it beautiful to know that while you're resting here, the universe is creating, always creating, 400 million stars every single day, 11 stars every second. And we're going to watch them being born. Tonight, we're going on a very special journey. We're going to drift through the universe's greatest stellar nurseries, those vast, glowing clouds where stars are born. But here's what makes tonight different. We're going to experience these births in ultra-slow motion, watching processes that take millions of years unfold. like a gentle lullaby. You see, the universe doesn't rush, it doesn't hurry. Stars aren't born in violent explosions like you might imagine. No, they're born in the slowest, most peaceful dance of gravity and light. We'll start our journey in the Orion Nebula, just 1,300 light-years from Earth, close enough that on winter nights, you can actually see it with your naked eye, that fuzzy star in Orion's sword. But tonight, we're going much, much closer. We're going to float right into its glowing heart, where 2,000 baby stars are slowly waking up, their first light taking centuries to establish its rhythm. We'll feel the warmth of protostars, these cosmic infants that haven't quite learned how to shine yet. But they're trying. Oh, they're gently trying. And from there, we'll drift to other nurseries. The Eagle Nebula, with its famous pillars of creation. The Carina Nebula, where stars are born in gardens of glowing gas. Each nursery has its own personality, its own gentle way of creating stars. Some are quiet and peaceful, others are vast and busy. But all of them share this beautiful secret, that the most powerful forces in the universe work slowly, patiently, like a cosmic lullaby that takes millennia to sing. The science is beautiful too, and I'll share it with you in the gentlest way. How gravity becomes like a loving embrace, pulling dust and gas together so slowly, so tenderly. How the first fusion reactions aren't violent at all, but more like gentle stellar heartbeats, tiny pulses of light that take centuries to find their rhythm. Everything about star formation is about patience, about time, about the universe taking its time to create something perfect. So, let yourself drift now. Let yourself float. Because we're about to leave Earth behind. We're rising up through the atmosphere, through the clouds, past the moon, and out into the gentle darkness of space. Can you feel how peaceful it is out here? How quiet. There's no rush, no hurry, just the slow, eternal dance of creation. And there, ahead of us, glowing like a cosmic rose in the darkness, is our first destination, the Orion Nebula, waiting to show us how stars are born. As we drift closer to the Orion Nebula, you can see it beginning to reveal itself. What looked like a single point of fuzzy light from Earth is now spreading out before you, 40 light-years across. That's about 235 trillion miles, a glowing tapestry of gas and dust, painted in the softest shades of pink and purple and gold. And you know what's amazing? This whole magnificent cloud, this stellar nursery, that's bigger than you can imagine. It's mostly hydrogen, the simplest element in the universe. The same stuff that makes up the sun. The same stuff that's in every drop of water on Earth. But out here, oh, out here it's different. The hydrogen is glowing, excited by the young stars that have already been born here. Their ultraviolet light makes the whole nebula fluoresce like a cosmic nightlight. So gentle, so beautiful. And as we float deeper into this cloud, you can feel the warmth. It's not hot, not at all. It's more like the warmth of a blanket that's been sitting in sunlight, comforting, embracing. Look around you now. Can you see them? The baby stars. They're everywhere, about 2,000 of them, in various stages of being born. Some are just a few 100,000 years old. Cosmic newborns, really, still wrapped in their cocoons of dust and gas. Others are maybe 1,000,000 years old, just beginning to clear away their birth clouds with gentle stellar winds. And the light they give off, it's not harsh or bright. It's soft, filtered through all this gas and dust, like candlelight through silk. Let's drift over to that glowing region there. See that concentrated area of light? That's called the trapezium cluster. 4 hot young stars that were born together about 300,000 years ago. They're like quadruplets, stellar siblings that formed from the same cloud of gas. And they're still so young that they haven't drifted apart yet, still holding close to each other in their cosmic nursery. The Native Americans could see these 4 stars with the naked eye. They called them the Lakota constellation of the heart of the bear. As we float past the trapezium stars, notice how the gas around them is being gently sculpted. They're stellar winds, which sound violent, but are really just streams of particles moving through space, are creating cavities in the nebula, hollow spaces where the gas has been pushed back. It's like watching someone blow very, very slowly into soap bubbles, the gas retreating and flowing in the most graceful patterns. And there, do you see that? That darker region that looks like a shadow against the glow. That's a protoplanetary disk, a baby solar system forming around a newborn star. Right now, in that disk, planets might be forming, worlds being born. Maybe, in a few billion years, someone on one of those worlds will look up at their night sky and wonder how they came to be, never knowing that you watched their world being born tonight. The Orion Nebula is special, you know. It's the closest star-forming region to Earth, close enough that the Hubble Space Telescope and now the James Webb Space Telescope have taken thousands of pictures of it, showing us details that would have seemed like magic to astronomers just 50 years ago. We can actually see individual protostars. Watch as they slowly gather material. Observe the exact moment when they begin to shine. But what makes this place truly peaceful is the timescale. Everything here happens so slowly. A protostar takes about 100,000 years just to gather enough material to begin fusion. That's longer than modern humans have existed. And then it takes another 10 million years to settle into a stable star like our sun. 10 million years of gentle adjustment, of finding balance, of learning how to shine steadily. Listen, can you hear it? Of course, there's no sound in space. But if there was, it wouldn't be explosions or roaring. It would be like a whisper, like the softest humming. These stars are being born in near silence, in profound peace. The violence you might associate with stellar birth. It's all been reframed by time, slowed down until it becomes a meditation. Now, let's talk about how this actually works. How gravity becomes a cosmic lullaby that builds stars. It starts with the tiniest irregularity, maybe just a region where the gas is slightly denser than its surroundings. Just a whisper more, hydrogen atoms in one spot, and gravity, patient, eternal gravity, begins its work. It pulls so gently you'd never notice if you were there, drawing in more gas, more dust. Think of it like this. Imagine you're watching a time-lapse of a puddle of water on a perfectly flat surface. How it slowly draws itself together. How surface tension pulls every tiny droplet toward the center. That's what's happening here. But instead of surface tension, it's gravity. And instead of water, it's hydrogen and helium and tiny grains of cosmic dust. The gas begins to rotate, not quickly. Oh no, impossibly slowly at first. One rotation might take 1,000,000 years, but as more material falls in, as the cloud contracts, it spins a little faster, like a figure skater drawing in their arms. Though even faster means maybe one rotation every 100,000 years, still so slow, so patient. And as the gas compresses, as gravity hugs it, tighter and tighter, over thousands of centuries, it begins to warm up. This isn't sudden. It's the gentlest warming you can imagine, like the way a compost pile warms from the inside. Slow biological processes generating heat, except here, it's gravitational potential energy converting to thermal energy, the universe's way of preparing to create light. The temperature rises from near absolute zero, maybe negative 400 degrees Fahrenheit, up to a few thousand degrees. But this takes millennia. Generations upon generations could live and die in the time it takes for the temperature to rise just 1 degree. And all the while, the cloud is contracting, condensing, like the universe is taking a deep breath that lasts 100,000 years. At the center, of this slowly spinning, slowly warming cloud, something magical is beginning. The pressure is building, not suddenly, but gradually. Over centuries, the hydrogen atoms are being pushed closer together, closer, closer. And deep in the core, conditions are approaching something special. The temperature reaching millions of degrees. The pressure becoming billions of times what we experience on Earth. And then, after 100,000 years of patient gathering and warming, fusion begins. Not as an explosion, but as the gentlest awakening. 4 hydrogen atoms finding each other, joining together to become helium, releasing just a tiny bit of energy. One fusion reaction, then another, like the first heartbeats of a stellar infant, uncertain at first, irregular, taking decades to find a rhythm. This is the moment of birth, when a protostar becomes a true star. And it's so gentle, so gradual. The star doesn't suddenly burst into light. It brightens slowly over thousands of years, like the slowest sunrise you could ever imagine. And the stellar wind begins, particles flowing outward, clearing away the birth cocoon of gas and dust, revealing the new star to the universe. Let's drift away from Orion now, floating through the darkness, between the stars. There's no rush. We have all night, all the time in the universe, and our next destination is 7,000 light years away. The Eagle Nebula, home to one of the most famous cosmic photographs ever taken. You've probably seen it. Those towering columns of gas and dust that NASA's Hubble Space Telescope photographed in 1995. They called them the Pillars of Creation. And tonight, you're going to float right through them as we approach. You can see why. They're called pillars. 3 massive columns of gas rising up like cosmic stalagmites. The tallest one is 4 light years high. That's about 23 trillion miles. So tall that light itself takes 4 years to travel from bottom to top. And they're not solid. No. They're made of hydrogen gas and cosmic dust, dense enough to block light, but still 1 trillion times less dense than the air. You're breathing right now. Float closer with me. Closer. Can you see the tips of the pillars? They're glowing, illuminated by young stars that have already been born here. Stars that are only about 2 million years old. Babies, really. And their light, their stellar wind, is slowly sculpting these pillars, evaporating them from the outside in, like cosmic erosion that takes millions of years. But here's what's truly magical. Inside these pillars, deep within where the gas is densest, new stars are being born right now. The pillars aren't just beautiful, They're stellar nurseries, cosmic wombs, where gravity is gathering gas into new suns. And we can drift inside. We can watch it happening. As we enter the first pillar, notice how the light changes. It becomes dimmer, redder. The dust is filtering out the blue light and letting through only the longest wavelengths. It's like being inside a cosmic sunset that lasts forever. And all around you, in pockets and knots, throughout the pillar, protostars are forming. There's one right there. See that glowing cocoon? That's called an egg, an evaporating gaseous globule. Astronomers love their acronyms, but forget the technical name. What you're looking at is a star that's maybe 50,000 years from being born. Right now, it's still gathering material, still contracting. The temperature at its core is maybe 1,000,000 degrees, not quite hot enough for fusion, not yet, but getting there, slowly, patiently. The pillars of creation are like a slow-motion sculpture being carved by starlight. The young hot stars outside the pillars, especially one called NGC 6611, that's just 2 million years old, are sending out streams of ultraviolet radiation. This radiation heats the surface of the pillars to about 20,000 degrees, which sounds hot. But the heating is so gradual, happening over thousands of years, that it's more like a gentle warming. And as the surface gas heats up, it evaporates, streams away in what astronomers call photoevaporation. The pillars are literally dissolving, but so slowly that they'll last another 3 million years. To us, they look eternal, unchanging, but they're actually in the process of disappearing. Just doing it on a timescale that makes human history look like the blink of an eye. You know what's fascinating? NASA's James Webb Space Telescope just took new images of these pillars in 2022 using infrared light that can pierce through the dust. And in those images, you can see straight through to the baby stars hidden inside. Dozens of them, all in different stages of formation. Some are just beginning to glow. Others are almost ready to clear away. They're birth clouds. Let's drift deeper into the pillar, following one of these forming stars. Watch as the gas swirls around it. Not quickly. Remember, nothing here happens quickly, but in a slow spiral that takes thousands of years per rotation. The gas is following magnetic field lines, invisible paths through space that guide the material into the growing protostar. And the colors, oh, the colors are so gentle here. Soft reds from the warm dust, pale greens from ionized oxygen, hints of blue from the hottest regions, but all muted, all softened by the vast clouds of material like looking at a rainbow through morning mist. As we float here, in the heart of the pillar, surrounded by forming stars, let me tell you about the mathematics of this place. Because even the numbers are soothing in their vastness. This whole Eagle Nebula complex is about 70 light-years across, containing enough material to make thousands of stars like our sun. And it's been making stars for about 2 million years. Will continue for maybe another million more. That means that since these pillars formed, about 2,000 stars have been born here. That's one new star every 1,000 years or so. And each one took its time, gathered its material slowly, ignited gently, joined the cosmic community without fanfare or explosion, just a gradual brightening over centuries. Now, let's leave the pillars and go deeper. Actually enter one of these protostars. See what it's like inside a star that's just about to be born. Don't worry, we're perfectly safe. This is all happening in ultra-slow motion. Remember, what would be violent heat and pressure is spread out over so much time that it becomes almost meditation. As we sink into the protostar, passing through its outer envelope of cool gas, the temperature begins to rise. At first, it's just a few hundred degrees, like a warm summer day. Then 1,000 degrees as we go deeper, 2,000, 5,000. But the journey inward takes us through regions that took hundreds of thousands of years to form. Each layer a different chapter in the star's biography. The gas here is mostly hydrogen, about 73%, with 25% helium, and just 2% everything else. All the heavier elements that will one day become planets, maybe even life. But right now, it's all mixed together in this cosmic soup, slowly organizing itself, slowly preparing for the miracle of fusion. Deeper still, 10,000 degrees now, 50,000, 100,000. The atoms are moving faster, but still in the context of what's about to happen. They're almost lazy, bumping into each other, bouncing apart, occasionally sticking together for a moment before the heat tears them apart again. It's like a very slow dance. Partners coming together, moving apart, coming together again. And at the very center, the core. This is where the magic is about to happen. The temperature is approaching 10 million degrees. The pressure is billions of times what we know on Earth. The hydrogen nuclei, those single protons, are being pushed so close together that they're almost touching, almost overcoming the electromagnetic force that keeps them apart. You see, hydrogen nuclei are all positively charged. They naturally repel each other, like trying to push the same poles of two magnets together. But gravity doesn't care. It just keeps squeezing, keeps pushing, patient and relentless. And at 10 million degrees, the nuclei are moving so fast that sometimes, just sometimes, they overcome that repulsion. When it happens, when 4 hydrogen nuclei finally fuse to become 1 helium nucleus, the energy released is tiny, less than the energy of a falling snowflake. But it's not just one reaction, it's trillions upon trillions, each one adding its whisper of energy. And over time, over centuries, these whispers become a voice, become a song, become the light of a new star. The first fusion reactions are sporadic, happening here and there throughout the core. No pattern yet, no stability. The star hasn't found its rhythm. It might take 1,000 years for fusion to become self-sustaining, for the reactions to generate enough heat to guarantee more reactions. And even then, it takes millions more years for the star to find its balance. You see, a star is always walking a tightrope. Gravity wants to crush it, to pull all that gas into a single point. But fusion pushes back. The energy flowing outward, holding gravity at bay, and finding that balance, that perfect equilibrium. It's like learning to breathe. The star might pulsate at first, brightening and dimming over centuries as it overshoots and undershoots, until finally, it finds that sweet spot. This is called the main sequence. When a star settles into its adult life, steadily fusing hydrogen into helium, shining with constant light. And our sun has been in this phase for 4.5 billion years, will continue for another 5 billion, just steadily, peacefully converting matter into energy. 4 million tons of matter every second, but so gently, so consistently, that life could evolve in its warmth. Now let's drift even further. 8,000 light years from Earth, to one of the most spectacular stellar nurseries in our galaxy, the Carina Nebula. And oh, if you think the Eagle Nebula was beautiful, wait until you see this place. It's 300 light years across. That's more than 4 times bigger than the Orion Nebula, a vast garden where stars bloom like cosmic flowers. As we approach, you can see why astronomers sometimes call it the Grand Nebula. It's not just one cloud, but a complex of bright nebulae and dark dust lanes, all woven together like a cosmic tapestry. The colors here are more vivid, more varied. Deep reds and oranges from glowing hydrogen, turquoise from doubly ionized oxygen, soft yellows from sulfur, all painted across the darkness in brush strokes that are light years long. And right at the heart of this nebula, there's a star that's almost impossible to comprehend. Eta Carinae, one of the most massive stars we know, about 100 times heavier than our sun. It's only 3 million years old, but it's already approaching the end of its life, burning through its fuel at an incredible rate. But even this giant was born the same way as every other star, slowly gathering from a cloud of gas, taking its time to ignite. Let's float through this garden of stars. See how different it is from the Orion Nebula, where Orion was subtle, gentle, almost intimate. Carina is vast and diverse. There are over 14,000 stars here, all born within the last 3 million years. That means a new star has been born here every 200 years or so. And they're still being born. Right now, as we drift through, look over there. That bright, sculpted region, that's called the Mystic Mountain, a pillar of gas and dust, 3 light years tall, and at its peak, hidden in those clouds, baby stars are being born. Their stellar winds are creating jets, streams of gas shooting out from their poles, but so slowly that they look frozen in time. These jets are moving at hundreds of miles per second, but they're so large that it takes them years to visibly change. The Hubble Space Telescope watched this region for 20 years, from 1919 to 2019. And in that time, astronomers could actually see the jets moving, see the pillars eroding, see new stars emerging from their cocoons. 20 years of watching, and the changes were barely perceptible. That's how slowly things happen here, how gently stars are born. You know what makes the Carina Nebula special? It's creating all different types of stars, not just medium ones, like our sun, but tiny red dwarfs that will burn for trillions of years, and massive blue giants that will live fast and die young. Well, young in cosmic terms, maybe 10 million years. Let's visit one of the smaller protostars forming here. This one will become a red dwarf, the most common type of star in the universe. It's been gathering material for about 200,000 years now, but it's still not quite ready to begin fusion. Red dwarfs are patient. They take their time, sometimes 500,000 years, to fully form. Float closer. Can you see how much smaller this gathering cloud is? It only has about 1/10 of the sun's mass, spread out over a region maybe the size of our solar system. And the temperature at its core is rising so slowly, maybe a degree every century. When it finally does begin fusion, it'll be different from larger stars, gentler, more efficient, red dwarfs, fuse hydrogen so slowly that they can last for trillions of years. Our sun will die in another 5 billion years. But this little star we're watching being born, it'll still be shining when the universe is 1,000 times older than it is now. It'll outlive galaxies, outlive everything we can see, just quietly, patiently, converting hydrogen to helium. Now let's drift to another part of the Carina Nebula, to a region called the Homunculus Nebula. This is different. It's not a star-forming region, but the shell of gas expelled by Eta Carinae about 170 years ago. But even this apparent violence, this great eruption, as astronomers call it, when viewed on cosmic timescales, was gentle. The star brightened over the course of years, expelled its outer layers over decades, created this beautiful bipolar shell that's still expanding today at about 400 miles per second, which sounds fast. But the shell is so large that it barely seems to move. In human terms, it was catastrophic. But in cosmic terms, it was just a star adjusting itself, finding a new balance. And here's something beautiful. The gas that Eta Carinae expelled, it's enriched with heavy elements. Carbon, nitrogen, oxygen, elements forged in the star's core. And this gas will eventually cool, mix with the surrounding nebula, and become part of new star-forming regions. The death throes of one star become the birth clouds of others. It's recycling on a cosmic scale. As we continue through Carina, notice how the stellar winds from all these young stars are creating bubbles in the gas. Each star clears out a little cavity around itself, and where these bubbles meet, the gas gets compressed. Sometimes this compression triggers new star formation, one generation of stars helping to create the next. It's happening right there. See that dense ridge of gas? That's where the stellar wind from a cluster of young stars is pushing against a molecular cloud, compressing it. The pressure is incredibly gentle by Earth standards, less than a billionth of what you feel from the atmosphere. But given millions of years, it's enough. Enough to start that slow collapse that leads to star formation. This is how star formation propagates through a nebula, like a very slow chain reaction, taking millions of years to spread from one region to another. The Carina Nebula has been forming stars in waves, first in one region, then another, like a garden where different sections bloom in different seasons, except the seasons last millennia. Let me tell you about stellar winds, because they're not what you might imagine. When we say wind, you might think of something violent, something that would tear you apart. But stellar winds are really just particles, protons and electrons, mostly, flowing away from stars, from a young star. These particles might be moving at 1,000,000 miles per hour, which sounds impossibly fast. But space is so empty that if you were floating here, you might feel one particle hit you every few seconds. It would be less than a gentle breeze, less than a whisper, more like being touched by individual photons of light. But given time, lots and lots of time, these gentle winds can move entire nebulae, can sculpt pillars and clear cavities, can compress gas clouds until new stars form. It's like water carving a canyon. If you watched for just a moment, you'd see nothing. But give it 1,000,000 years, the stellar wind from our own sun is called the solar wind, and it's been blowing for 4.5 billion years. It's carved out a bubble in interstellar space called the heliosphere, about 20 billion miles across. Our entire solar system sits inside this bubble, protected from the harsher interstellar medium. And it was carved so slowly, so patiently, atom by atom, over billions of years, in the Carina Nebula, with its 14,000 young stars. The combined stellar winds create a kind of cosmic weather system, streams of particles flowing in different directions, meeting, mixing, creating eddies and currents. But it all happens in such slow motion that to us, it looks perfectly still. Imagine if you could speed up time. Watch 1,000,000 years pass in a minute. You'd see the nebula churning like a pot of slowly boiling soup. Pillars rising and falling, cavities opening and closing, new stars popping into existence like bubbles. But at the speed we experience time, it's all frozen. A snapshot of a process that takes longer than civilizations. And in between the stellar winds, in the quieter spaces, dust is gathering. Tiny grains of silicon and carbon, smaller than smoke particles, are clumping together. These dust grains are important. They're the seeds around which planets will eventually form. Every rocky planet, including Earth, started as dust grains in a stellar nursery. The dust is mixed with ice too, frozen water, methane, ammonia, all the volatile compounds that will become comet nuclei and the atmospheres of giant planets. Right now, in the Carina Nebula, the ingredients for thousands of solar systems are being mixed together, sorted by stellar winds, prepared for the next generation of star and planet formation. Let's journey now to something truly special. 5,000 light years away, floating in the constellation Monoceros, there's a nebula there that looks exactly like its name, the Rosette Nebula. a cosmic rose, blooming in the darkness of space. And it's so perfect, so symmetrical, like the universe decided to create a flower out of stars and gas. As we approach, you can see why astronomers fell in love with this place. The nebula is arranged in petals, layers of glowing gas that spiral out from a central cavity, just like a rose. It's 130 light years across, so large that light takes more than a century to cross from one side to the other. And the colors, oh, the colors are so soft here. Deep reds at the edges, fading to pale pink, with hints of white and gold. Where the newest stars are shining, the cavity at the center that's been carved out by a cluster of young stars called NGC 2244, about 2 million years old. Their combined stellar winds have pushed the gas outward, creating this hollow space about 50 light years across. And the pressure from their winds is still pushing, still sculpting, making the rose bloom wider and wider, though so slowly you'd never notice. Float with me into one of the petals. Notice how the gas here is denser, cooler. It's about -400 degrees Fahrenheit, which sounds cold, impossibly cold. But for a nebula, that's actually quite comfortable, perfect for star formation. And if you look closely, you can see them, dozens of protostars embedded in the petals, like seeds in a flower. Each petal is actually a shock front, a place where the stellar wind from the central stars is pushing against the surrounding molecular cloud, compressing it. And in that compression, in that gentle squeeze that's been happening for 2 million years, new stars are being triggered into existence. The parent stars are literally giving birth to the next generation. The Rosette Nebula is creating stars in a very orderly way, from the inside out. The central stars formed first, then their winds triggered formation in the inner petals. And now it's spreading to the outer petals, like ripples in a cosmic pond. But ripples that take millions of years to spread. There's one protostar here, just beginning its journey. It's only been gathering material for about 50,000 years, still has maybe 200,000 years to go before fusion begins. But already you can see the rotating disk forming around it, the same kind of disk that planets will eventually form from right now. It's just gas and dust. But in a few million years, there might be worlds. You know what's beautiful about the Rosette Nebula? From Earth, amateur astronomers can photograph it with just a small telescope and a camera. It's one of the most popular targets for backyard astronomers. And when they take long exposure images, letting the light accumulate for hours, they can see the same structure we're floating through now. The same rose, blooming in space. The Spitzer Space Telescope, one of NASA's infrared observatories, studied this nebula for years. It could see through the dust to the baby stars hidden inside, and it found something wonderful. The stars here are forming in families, in groups, not alone. Most of the protostars have companions, binary systems, sometimes triple systems, all forming together from the same cloud. Let's visit one of these forming binary systems, two protostars spiraling around each other. Though the spiral is so slow that one orbit takes 10,000 years. They're connected by a bridge of gas, sharing material, feeding each other. Eventually, they'll become a double star system, two suns orbiting their common center of mass. And any planets that form here will have two sunrises, two sunsets, the sky painted with double shadows. The gas between the protostars is flowing in streams, following magnetic field lines that connect them. It's like watching honey pour between two bowls, but honey that takes centuries to flow. The material spirals down onto each protostar, adding mass slowly, steadily, and as they grow, their gravity affects each other, keeps them dancing, keeps them bound. Sometimes, in binary systems like this, one star will form faster than the other. It'll begin fusion first, and its stellar wind will affect its companion, might even blow away some of the companion's gas, limiting how large it can grow. It's like stellar sibling rivalry, but played out over millions of years, so slowly that it's more like a gentle negotiation than a competition. The mathematics of binary star formation is incredibly complex, but also incredibly beautiful. The two protostars have to balance their individual collapse with their mutual orbit, have to share angular momentum, have to find a stable configuration. And nature does this automatically, without thought, without planning, just through the patient application of gravity and time. As we drift through the Rosette Nebula, through its petals of gas, let's think about those numbers. I mentioned at the beginning 400 million stars being born every day in the universe. 11 stars every second. It seems impossible, overwhelming. But now that you've seen these nurseries, seen how slowly, how gently it happens, maybe it makes more sense. You see, the universe is vast. There are over 2 trillion galaxies that we can observe, and each galaxy has billions or even trillions of stars. And in each galaxy, there are thousands of nebulae, like the ones we're visiting, thousands of stellar nurseries, all slowly, patiently creating new stars in our own Milky Way galaxy. about 7 new stars are born every year. That doesn't sound like much, but the Milky Way is just one galaxy among trillions. In the nearby Andromeda galaxy, it's about 10 stars per year. In starburst galaxies that are experiencing rapid star formation, it might be hundreds or even thousands per year. Add them all up, all the galaxies, all the nebulae, all the slowly forming protostars, and you get that incredible number, 400 million per day. But now you understand that they're not all forming at once in some cosmic explosion. They're forming slowly, gently, spread out across billions of light years of space, right now, as you're listening to my voice, drifting deeper into rest. Somewhere in the universe, a protostar is experiencing its first fusion reaction. 4 hydrogen atoms are coming together for the first time, releasing that tiny whisper of energy. And somewhere else, a different protostar is finally gathering enough mass to begin heating up. And somewhere else, a molecular cloud is just beginning to collapse. It's happening everywhere, all the time. This gentle process of creation, the universe, is like a vast garden where flowers are always blooming. But each flower takes 1,000,000 years to open. And we're lucky enough to live in a time when we can see it happening, can understand it, can appreciate the profound peace of stellar birth. Let me share something that astronomers have recently discovered using radio telescopes, which can peer through the dust that blocks visible light. They found that star formation is even more common than we thought. There are stellar nurseries hidden behind veils of dust, invisible to optical telescopes, but there, nonetheless, quietly making stars. The ALMA telescope in Chile, the Atacama Large Millimeter Array, has revolutionized our understanding of star formation. It can see the cold gas, the stuff that's just beginning to collapse before it even starts to glow. And it's shown us that the process is even gentler than we imagined, even more gradual. ALMA has watched protostars in the Rosette Nebula that are so young, so early in their formation, that they don't even have disks yet, just irregular blobs of gas, slowly finding their shape, slowly deciding what kind of star they want to become. It's like watching clouds form in ultra-slow motion, each tendril of gas taking decades to move. And here's something that might help you sleep. The rate of star formation in the universe is slowing down. Peak star formation happened about 10 billion years ago, when the universe was young and full of gas. Now, the rate is about 1/10 of what it was then. The universe is settling, calming, moving toward a quieter future. But don't worry, stars will continue forming for trillions of years to come. The smallest red dwarfs that are being born right now in the Rosette Nebula, in Orion, in Carina, they'll still be shining when the universe is 100 times its current age. They'll be the last lights in the cosmos, gentle, patient, outlasting everything. Think about that. The stars, being born today, are the universe's investment in the future. Each one a small flame that will burn for eons. And they're being lit so gently, with such patience. It's like the universe is carefully, methodically ensuring that there will always be light, always be warmth, always be the possibility of life. The math is beautiful in its simplicity. Take the total amount of gas in all the galaxies, divide by the rate of star formation, and you can calculate how long stars will continue to be born. The answer is about 100 trillion years. That's 10,000 times the current age of the universe. We're still in the very beginning of the stellar age, still in the cosmic morning. Now, let's drift even deeper into the mathematics of all this, the beautiful, soothing numbers that govern how 400 million stars can be born every single day. And I want you to know, these numbers aren't cold or abstract. They're like a lullaby, written in the language of the cosmos. Each equation, a gentle verse. Each calculation, a soft refrain. Think about this. 11 stars, beginning their life every second. That means, in the time it takes you to take one slow breath, in and out, maybe 40 new stars have started glowing. Somewhere in the universe, 40 new suns, 40 new possibilities, 40 new centers of warmth in the cold darkness. And they're all being born the way we've been watching, slowly, gently, patiently. The universe has about 10 to the 22nd power stars. That's a 1 with 22 zeros after it. It's a number so large that if you tried to count them, 1 per second, it would take you 30 trillion years, longer than the universe has existed, longer than it will exist in its current form. But here's what's beautiful. Each one of those stars was born in a nebula. Each one took its time. Each one was once a slowly rotating cloud of gas. Let's float here for a moment and really feel these numbers. When astronomers say 400 million stars per day, they're averaging across the entire observable universe. In some galaxies, the rate is much higher. In others, it's slowing down, like a garden where some beds are in full bloom, while others are resting. There are special galaxies called starburst galaxies, where stars are forming 1,000 times faster than in the Milky Way. Imagine that. Thousands of new stars every year in a single galaxy. But even there, even in those cosmic fireworks, each individual star still forms slowly, still takes 100,000 years to begin fusion. The burst is just that. There are more nurseries, more places where the slow process is happening. The nearest starburst galaxy is Messier 82, about 12 million light-years away. NASA's telescopes have been watching it for decades, and in infrared light, you can see hundreds of stellar nurseries, all active at once, like looking at a garden where every rosebud is opening simultaneously, but each one still taking its sweet time. You know what determines how many stars form? It's actually very simple. It's all about gas, cold, molecular hydrogen gas. That's the raw material, the cosmic clay from which stars are sculpted. And the universe started with a finite amount. About 73% of all ordinary matter is hydrogen, created in the first few minutes after the Big Bang. Some of that hydrogen has already been used, locked up in existing stars, in white dwarfs, in black holes. But most of it, about 90%, is still out there, still available, still waiting to become stars. And at the current rate of 400 million stars per day, we're using up about 1 billion solar masses of gas per year across the universe. That sounds like a lot, and it is, but compared to the total amount available, it's tiny. It's like taking a cup of water from the ocean. The universe has enough hydrogen to keep forming stars at this rate for another 100 trillion years. The stellar age is just beginning. We're watching the opening notes of a symphony that will play for eons. Let me tell you about something called the initial mass function. It's one of the most beautiful patterns in astronomy. It describes how many stars of each size are born. And it turns out, nature has preferences. For every massive star that forms, there are hundreds of medium stars, like our sun, and thousands of small red dwarfs. It's like a cosmic recipe that never changes. No matter which nebula you visit, no matter which galaxy, the proportions are always roughly the same. 1 giant star, 10 sun-like stars, 100 small stars, 1,000 tiny red dwarfs. Nature loves making small stars, the gentle ones, the patient ones that burn for trillions of years. This pattern, this preference for small stars, it means that most of those 400 million daily births are creating modest, quiet stars, stars that will never explode, never become black holes, just steadily shine for longer than we can imagine. Each one a small, reliable heartbeat in the cosmic body. The temperature matters too. For a gas cloud to collapse into stars, it needs to be cold, really cold, about 10 degrees above absolute zero, negative 440 degrees Fahrenheit. Any warmer and the gas molecules are moving too fast. They won't clump together, won't begin that slow collapse. This is why star formation happens in molecular clouds, the coldest places in the universe. Places where the gas is so cold that atoms bond together into molecules, hydrogen pairs, carbon monoxide, simple things, but cold enough to be still, cold enough to be gathered by gravity's patient hand. And cooling takes time. When gas is heated by a nearby supernova or stellar winds, it takes millions of years to cool back down, to become ready for star formation again. It's like the universe has to rest between creative periods, has to gather its strength, has to prepare for the next round of gentle stellar births. There's a beautiful relationship between the size of a star-forming region and how long it lasts. Small nebulae, just a few light years across, might form stars for 1,000,000 years, then dissipate. Large ones, like Carina, hundreds of light years across, can keep forming stars for 10 million years or more. The bigger the garden, the longer the blooming season. And within each nebula, there's a cascade effect. The first generation of stars, their winds compress the gas nearby, triggering the second generation, which triggers the third. It can go on for dozens of generations, each one seeding the next, like a very slow game of cosmic dominoes, where each domino takes 1,000,000 years to fall. Right now, in nebulae across the universe, this cascade is happening. In the Orion Nebula, the trapezium stars are triggering new formation in the gas around them. In Carina, Eta Carinae's winds are compressing clouds that will become stars in 1,000,000 years. Each stellar generation preparing the way for the next. The Tarantula Nebula. Oh, we need to visit the Tarantula Nebula. It's not in our galaxy. It's 160,000 light years away in the large Magellanic Cloud, a small galaxy that orbits the Milky Way. But it's the most active star-forming region we know, the busiest stellar nursery in our corner of the universe. As we drift across the immense gap between galaxies, through the empty darkness of intergalactic space, you can see it ahead, glowing like a cosmic beacon. It's called the tarantula because the loops and filaments of gas look like spider legs, stretching out across 1,000 light years. But there's nothing scary about it. It's beautiful, magnificent, a place where stars are being born at an incredible rate. The Tarantula Nebula is creating stars so enthusiastically that if it were as close as the Orion Nebula, just 1,300 light-years away, it would cast shadows on Earth at night. It would be as bright as the full moon, a glowing cloud covering a quarter of our sky. But from this distance, from Earth, it's just a fuzzy patch in the southern sky, visible only from the southern hemisphere. As we enter the nebula, you can immediately feel the difference from the others we've visited. There's more energy here, more activity, but still happening in that slow, cosmic way. The gas is warmer, excited by thousands of young stars, glowing in brilliant blues and greens alongside the familiar reds. At the heart of the tarantula is a cluster called R136. It contains several stars that are over 100 times the mass of our sun, some possibly 300 times. These are the giants, the monsters, burning so hot that their surface temperature is 70,000 degrees. But even these titans were born the same way, slowly gathering from gas, taking hundreds of thousands of years to form. The entire Tarantula Nebula contains about 500,000 solar masses of gas, enough to make hundreds of thousands of stars. And it's been forming stars for about 20 million years. Will continue for maybe another 10 million. In that time, it will have created over 1 million stars, contributed millions to that daily count of 400 million. Look at the structures here: pillars and cavities, sheets and filaments, all sculpted by stellar winds from different generations of stars. It's like looking at a piece of cosmic art that's been worked on by thousands of artists, each adding their own touch, their own pressure, their own light, but all working so slowly that the artwork takes millions of years to evolve. The James Webb Space Telescope recently spent days staring at the Tarantula Nebula, taking the deepest infrared images ever captured. And in those images, we can see protostars that have never been seen before. Thousands of them, all in different stages of formation. Some still embedded in their dusty cocoons, others just beginning to clear their surroundings. One region, called the Honeycomb Nebula, because of its appearance, is particularly active. New stars are forming there in chains, in clusters, following the filaments of gas like beads on a string, each one influenced by its neighbors, each one contributing to the collective stellar wind, the collective warming, the collective beauty. The rate of star formation in the tarantula is about 1,000 times higher than in a typical nebula. That means instead of one star every 1,000 years, it's more like one star every year. But remember, That's still slow by human standards, still gentle. Each star still takes its 100,000 years to form. There are just more of them doing it simultaneously. You know what makes the Tarantula Nebula so special for understanding that number? 400 million stars per day? It's that this single nebula, this one star-forming region, is contributing about 1/10,000,000th of all star formation in the universe, one nebula among billions. Yet we can see it, study it, understand it. If we multiply what's happening in the tarantula by 10 million, spread across all the galaxies, all the nebulae we can't even see, we get our 400 million daily stars, each one forming just like the ones we're watching here, slowly, patiently, gently. The gas in the tarantula is moving, swirling in vast currents that take millennia to complete one rotation. You can see the density waves, places where the gas bunches up, becomes more likely to collapse. These waves move through the nebula at about 10 miles per second, which sounds fast. But the nebula is so large that one wave takes 100,000 years to cross it, and in the wake of each density wave, new stars begin to form. It's like watching very slow ripples on a cosmic pond, where each ripple leaves behind a trail of newborn stars. The pattern is hypnotic, mesmerizing. The same process, repeating over and over, but each repetition taking longer than human civilization has existed. As we slowly drift away from the Tarantula Nebula, beginning our gentle journey back home, let's carry with us this profound understanding. 400 million stars born every day, not in violence, not in chaos, but in the slowest, most patient dance of gravity and time. Each one a small miracle that takes 100,000 years to unfold. Each one a gentle light that will shine for billions or even trillions of years. You've traveled so far tonight, through Orion with its 2,000 baby stars, through the pillars of creation, where stars are hidden in cosmic cocoons, through the vast gardens of Carina, the rose-like beauty of the Rosette Nebula, and finally to the busy tarantula, where stars bloom like flowers in spring. And in each place, you've seen the same beautiful truth, that creation is gentle, that the universe builds slowly, carefully, with infinite patience. We're floating back now, back through intergalactic space, back toward the Milky Way, back toward that small blue marble orbiting an ordinary star, a star that was born 4.5 billion years ago in a nebula, probably much like the ones we've visited. Took its own 100,000 years to ignite, found its balance, and has been steadily, gently shining ever since. And as we drift, as you sink deeper into rest, deeper into peace, remember that right now, this very moment, 11 more stars have just begun to shine. 11 more points of light in the infinite darkness. 11 more reasons for the universe to continue, to persist, to create. If you're still awake, still floating through the cosmos with me, that's perfectly okay. Some nights, our minds need a longer journey, need more time among the stars. And you know what? There's another story waiting for you, another gentle adventure through space and time. Maybe you'd like to learn about how planets form from the leftover dust of stellar nurseries, or how galaxies slowly dance around each other over billions of years. Or perhaps you'd like to visit the moons of Jupiter, each one a world of its own. The next video is already there, ready to play, ready to carry you even deeper into rest. You don't need to move, don't need to reach for anything. Just let it flow into the next journey. Let my voice continue to guide you through the cosmos. The universe never rushes, never hurries, and neither should you. If sleep hasn't found you yet, it will in its own time. Just like those protostars we visited, gathering their material slowly, finding their rhythm gradually. There's no pressure, no urgency, just the gentle continuation of our cosmic exploration. Video after video, story after story, until your mind finally finds that perfect moment to let go. But for those of you who are ready, who are feeling that beautiful heaviness in your body, that soft fog in your thoughts, this is your invitation to drift away. You've earned this rest, this peace. After witnessing the birth of stars, after understanding the profound patience of the universe, you can release any need to hold on, any need to keep listening. Thank you. Thank you for joining me on this journey through stellar nurseries, for letting me share with you the gentle mathematics of creation, the slow poetry of star formation. Your presence here, your willingness to explore the cosmos with wonder instead of fear. It makes these stories worth telling. As you drift off, as sleep begins to embrace you like a warm nebula, remember what you've learned tonight. The universe creates constantly, but never frantically. 400 million stars every day, but each one taking its time. Each one a lesson in patience, in persistence, in peace. You are made of star stuff. Every atom in your body, except hydrogen, was forged in the heart of a star. You are literally the universe experiencing itself And just as stars are born gently, slowly, you can let sleep come to you the same way. No forcing, no rushing, just the gradual, natural transition from waking to dreaming. The stellar nurseries will continue their work while you sleep. Orion will keep glowing. Carina will keep creating. The rosetum will keep blooming. And tomorrow night, if you want, we can visit them again, or explore new wonders, new mysteries. The universe is vast, infinite, and there's always more to see, always more peace to find in the cosmic dance. Close your eyes now, or let them stay open if that feels better. It doesn't matter. What matters is that you know you're safe, you're held, you're part of something beautiful and eternal. The same forces that birth stars are watching over you. The same patience that builds suns is here with you now. Sweet dreams, my dear friend. May your sleep be as deep as space, as peaceful as a nebula, as gentle as starlight. May you drift through your own inner cosmos tonight, discovering worlds of rest, galaxies of dreams, nebulae of perfect peace. The stars are being born, slowly, gently, 400 million of them each day. And you are here to witness it, to understand it, to be part of it. What a magnificent thing. What a beautiful reality. What a perfect note to end on. Good night. Sleep well. And remember, somewhere in the universe, right now, a star is taking its first breath, beginning its billion-year journey. Just as you begin your journey into dreams, sweet dreams among the stars.